there, it's Katie with TutorPUG, and I want to walk you through some very easy derivatives. These are just the drop and flop rule. This is the rule that I call drop and flop, and it occurs when you have a variable base raised to a numerical exponent. The location and behavior of the variable determines which derivative gets used every single time. So on this, I have a coefficient of 3 times a base of x raised to an exponent of 2. The vocabulary is very important. Coefficient, base, exponent. When I derive this, and I will indicate that I am finding the derivative by putting the tick mark there. Be careful. You want to use the tick mark when you're finding the derivative. And if you're not deriving, don't use the tick mark. So this exponent is going to drop down. I call it drop and flop. Drops down, multiplies by whoever's there, flops back 1 unit. You subtract 1. So the derivative of this, 2 times 3 is 6. 2 minus 1 is 1. This guy is also a drop and flop, but he's also a very simple derivative rule. Think of that as an invisible 1. 1 will drop down and multiply by 2. 1 times 2 is 2. 1 minus 1, because he has to flop back 1 unit, is 0. So this would give me 2x to the 0, but anything raised to the 0 power is 1. So when I derive this, I wind up with 2 times 1, which is just 2. This is a constant. It's a number that will never change because there is no variable associated with it. The derivative of any constant is 0. It goes away. It's a drop and flop. Here's why it goes away. I could pretend that there is an invisible x to the 0 right there because x to the 0 is 1. And if I pretend that I'm multiplying 4 by 1, it doesn't change the value of 4. If I pretend that there is an x to the 0 right there, and I do drop and flop, the 0 will drop down and kill the constant. So it's technically a drop and flop rule. But if you just want to remember that the derivative of a constant is 0, that's fine. Here's our next one. These are all still drop and flops. They are all drop and flops, even though they look a little bit scary. Pi's and e's kind of make people nervous, but remember, pi is a constant. If everybody goes to their calculator and we all type in the pi key, the calculator is going to show the same number to everybody. Same thing for e. E by himself is a constant number. So the derivative of x to the pi is going to be a drop and flop. Pi x to the pi minus 1. This is e to the pi times x. So it's technically behaving just like 2x. And recall, the derivative of 2x is just his coefficient. The derivative of whatever x is just that whatever coefficient. So this derivative is e to the pi. And this, as funny looking as it is, pi to the e is a constant. It's never going to change. The derivative of a constant is 0. It goes away. So this is my derivative. Lastly, I have k of x, and I have all kinds of variables under radicals and in denominators, and that's okay. They are all still drop and flops. They're dressed up to look scary, They're not a wolf in sheep's clothing, they are a sheep in wolf's clothing. They look scary, but they're really not. It's just a sheep when you take its costume off. So I have to do some pre-calc first. And you must remember that when you have a variable under a radical sign, you can rewrite it without the radical. The exponent on this floats to the top of a fraction exponent. The index becomes the denominator. So the square root of x is x to the 1/2, because that's an invisible 1 and that's an invisible 2. If you want to pull something out of a denominator, then you bring the denominator to the top. Something has to change. All that changes is the sign on the exponent. So instead of x to the positive 4, when I bring it up, that turns into a negative 4. This is just like that rule. Minus 3x, okay, I want to kill the radical. This number floats to the top. That number is the denominator. And this combines both rules. Convert the radical and pull it out of the bottom. So this last term becomes 6.1 times x to the negative 19/5. I have not done calculus. I have just rewritten it using pre-calculus. I have not put my tick mark there. This is not the derivative. And be careful, because sometimes after you expend this brain power or brain energy remembering how to rewrite it, we think, oh, thank God that's over, drop your pencil and walk away. You haven't derived it. You still have to do that. So now when I derive this, k prime of x, I can see that everywhere I have a variable, the variable is the base and it's holding a numerical exponent, like a boy holding a balloon, which makes them all be drop and flops. So here, I drop my 1/2 down. 1/2 minus 1 is negative 1/2. Here, I drop the negative 4 down. Negative 4 times positive 4 is negative 16. Negative 4 minus 1 is negative 5. Drop and flop. Here, 7/3 drops down and multiplies by the negative 3, which gives negative 7x. 7/3 minus 1, 7/3 minus 3/3 is 4/3. And here, I'm going to drop and flop. Well, I don't know what 6.1 times negative 19/5 is off the top of my head. So I will just write it as 6.1 times negative 19/5 x, negative 19/5 minus 1, negative 19/5 minus 5/5 is negative 24/5. And I've run out of terms, so I'm done. This clearly indicated, there's my tick mark, this is the derivative of these functions. This is the function as it was originally written. This is after I pre-calc and converted a little bit. This is the derivative. If you want to go to your calculator and multiply 6.1 times negative 19/5 and write down that number, either as a decimal or as a fraction, you can, but you do not have to. Practice these. I'll get you some in the show notes to practice. The only way you get better is to practice. I have some more videos that increase the level of difficulty and talk about different rules, so check those out, and happy mathing!